Good morning, everybody. Just a reminder to either turn off or silence your cell phones during the presentation. If during the presentation you want to ask questions of the speaker, we'd also like to ask you to queue up at either of the two microphone stands and ask your question into the microphone so that everybody can hear it. It is day 4 of 23C3. It is 11:30, an ungodly early hour. And it is time for a presentation on unusual bugs. Our speaker is a returning speaker, and I will hand it over to him. His name is Ilya, so welcome him. Welcome, Ilya.
This thing on? Yeah, okay. Good morning, everybody. Yeah, so as the Herald just said, it's way too early, and I haven't really slept that much because, you know, day before you still have to finish some of your slides, things like that. So let's just get started. Who am I? My name's Ilya. I love to see things crash and burn and aim for something expensive in the process. Work for a small security company called SureSec. I'm part of a security group called Netric. I have a blog and a website. If you think I'm interesting, you should go there. The things I'll be talking about today. Null pointer references. So first thing I'll talk about, Stack Overflow, shifting the stack pointer, reference counting, issues with reference counting. One particular case of file race conditions where everybody thinks you're doing it right, but you're actually not. Some issues with regular expressions, and then if I have time left, I'll talk about some issues writing to fixed file descriptors in libraries. And then at the end, I'll actually do a tool release. Right, so let's just dig right in. The things I'm going to talk about are not really big secrets, although some people like to pretend they are. Most of these things have been mentioned in one way or form or shape somewhere on the internet, but apparently not that many people have read them, or even if they've read them, they haven't entirely understood them. And I sort of have the same thing, right? Because I do a fair amount of code reviews, and you run into some things and you go like, well, you know, I wonder what would happen if, you know, you do this and this and these things, and, you know, how would this, you know, this particular piece of code react to it? And so, you know, you start looking into these kind of things, and you know, you find some interesting things, and then you do some Google search on these things, and you see that somebody else, you know, at some point in the past has already looked into these things, but it turns out that not that many people actually know about it. I'll have some demos. Actually, I'll have one, because I had another one, but that one didn't get finished. Just to show that, you know, most of this stuff is not really theoretical. And I'm doing this because I've done a similar talk a couple of months before at RuxCon, and people liked it, but they went like, you know, it's all, you know, it's theoretical and stuff. And it's really not, just that at the time, I didn't have enough time to make demos. I'll show you one demo. This stuff is not just theoretical, right? This can actually happen. You can write exploits for these kinds of things. And most of it is ongoing research. It's not finished. There's probably a whole lot of stuff I don't know yet, and feel free to contribute. So null pointer references. I found a quote about this. I'm not going to say the entire thing because it's way too long, but this was said by one of the Opera browser developers, and at the end he says, you know, ordinary null pointer crashes that have no possibility whatsoever to be abused. He's wrong, and I will tell you why. So as this guy as I just showed you in the quote, most people consider null pointers to be non-exploitable, right? Because the address that you're referencing is usually not mapped. And so people go like, well, you know, at most there's a denial of service. You know, if it's local in a browser or whatever, it's not even a denial of service, right? It just blows up and that's it. So first of all, if you have a null pointer reference, sometimes you don't even need this particular page to be mapped. There's basically two cases that I've come across where you would have some kind of issue with a null pointer and where the page doesn't actually have to get mapped. The first one is where you get your null pointer and you add some offset to it where you have a lot of control, you know, where the offset's really big. And then you get to write to, then basically the offset will get used as an absolute address. And the second one is basically where you have a null pointer of, you know, that came back from some, you know, malloc or whatever, and where it gets passed to another function where null has some special meaning. And one example is strutdoc_r. And I'll give you two examples of these things. This is one, I know it looks ugly. I've already tried to clean this up. It comes from Procmail, so you know, I've done my best. So basically what's going on here is they basically call this function where they add a byte to a piece of memory. And so they have some bookkeeping where they see, you know, if this byte doesn't fit in memory, we'll relocate, and then once we relocate it, we'll use this offset from our bookkeeping inside this chunk of memory and write our byte to it. And basically, so yeah, these two functions here basically get called this thing here, and these functions get called from within Procmail. So basically, what this does is, if it's the chunk they want to write to is not big enough, they relocate. And the problem they have is they don't check the return value of realloc. So it can return null, right? If there's not enough memory, it'll do that. And so they do null, and then they add this offset to it, which is in their bookkeeping, and then you know they use the offset as an index, and then write your byte to it. So if realloc fails, this offset really actually becomes an address instead of just an offset. And so basically, if realloc fails, you get to write to some piece of memory you're really not supposed to write to. Basically, user-defined byte. And this one is, you know, as far as I've seen, pretty much exploitable. It takes some poking, though, because it's not that easy. The second case is where, you know, you pass a null pointer to a specific function. And this particular piece of code, which is also quite nasty, comes from X. You know, you wouldn't expect this because, you know, X is known for their code quality. So this is another case where, you know, they do some kind of memory allocation and they don't check return values used. And so in this case, it's a string duplicate, which is basically just a wrapper around malloc. And then, so SP namelist can potentially be null, a null pointer. It gets passed on to this thing called strutdoc_r. And this function, strutdoc_r, has this special casing where if the SP namelist, in this case, is null, instead of using SP namelist, they'll use talkLast. And so the thing that strutdoc usually does is it takes this argument and scans this string, and then if it sees it, it changes it with a null byte, basically, because it's basically it splits up a string, right? And but in this particular case, if this thing is null, it will use this pointer. The problem being that the first time you call it, this pointer is actually not initialized. So if you get this special case where you get null, but this pointer is not yet initialized, then this pointer could potentially be anything, right? It's just a piece of uninitialized memory. In this case, it's on the stack, right? So, you know, with some fiddling around, you could sort of define that. And so basically, you get to make this thing an arbitrary pointer and then get some memory corruption done, because if it looks for a string and if it from that where it points to up until a null byte, and if it sees any column, it will just override it with a null byte. So I've described the steps here basically. And if it overrides it with a null byte, that's basically memory corruption. This is bad because, you know, we've seen this before. It leads to code execution. Right, so those are the two cases where you don't need your null page mapped. People know these things, but these kind of cases are somewhat rare. They happen, but they're rare and they're usually fairly hard to spot because it's usually in ugly code like Procmail or X or something like that. Let's not talk about these two cases, but others. If you think about null pointers, null is just another address, right? It's 0x0000 basically, right? It's a valid address. There's no universal rule that says this page can be mapped, right? It can be mapped, it can be there, it could be used, right? Perfectly if it's in your virtual address space. So the question is, how can we force an application to map this page, you know, and force it to map it before this application references a null pointer, right? So in what context can we do this? And it turns out that these things are a little bit operating system specific. Talk about some cases. There are some cases I don't know yet about, or haven't looked too much into it, but I hope this will satisfy you. So the first case I looked at is it's mapped by default. It's already there. There's data on it. You could use it. The page is at least readable and there's some kind of data on it. Turns out that somebody had already written exploits for something similar like this about 12 years ago. So, this is one of these cases where you go look for something and, over a decade ago somebody else did this too. And it's done by a group called 8LGM, who were madly skilled and did some really awesome stuff in the late 80s and early 90s. And so they had this exploit for SCU Unix, and so you can see it was done in 1994, and they basically, they have this hilarious bug. You can read it if you want to. And basically they say, if your operating system maps it by default, which, SCU at the time used to do, then you can just read or write. I think in this particular case, only read from this page. But in this case, it was more than enough. So this was the first publicly documented null-pointer reference exploit I could find. So, and I don't really know any operating systems today that map this page by default and give you some attributes where you can at least read or write it. Maybe SU still does it. I have no idea because, well, I don't use, Unixware, OpenServer, any of that kind of thing. So, let's look at the second case of where you could potentially exploit null pointers. The kernel, your kernel. And this is usually where you're in kernel mode but still in user context. And depending on your operating system and your architecture, if you're in kernel mode but user context, your virtual address space is shared. So the kernel can basically just reference your virtual memory directly without, doing some kind of weird transition. And so this means that if the kernel has a null pointer, before you trigger it, you could just map it in userland and then trigger it in the kernel, and it will actually use the same null page that you just located. And the way you locate a null page in Unix is you use mmap, and you're specifically given a flag which says, so the first address is first argument is usually the address, but in most cases this is just a hint, right? So people usually don't set it. It's just, if you have it available, please give it to me, but it's not a requirement. And so usually what you end up doing is people just, in the kernel, this argument gets ignored. Unless you say map fixed, and then it says, give me this address or fail. And so if you want to locate the null page, you say, give me the null page or fail. And most operating systems that I've tried it on, Linux, FreeBSD, OpenBSD, NetBSD, and a few others, they allow you to map the null page. There's no specific rule that says you can't do this. If you specifically ask for it, you get it. And so you use mmap to basically map it. Of course, exploitability still depends, right? It depends, like if the kernel has a null pointer dereference, it depends on what it's doing with it. If it's just touching the page and reads some dumb value of it but doesn't do anything else from it, you might get a kernel panic out of it, but that would be it. On the other hand, for example, if they use it and they think it's some kind of structure which contains a function pointer, and then they would execute this function pointer, well, then these kind of things become exploitable. So a lot of them are exploitable, some are not. The large majority of them are. And so I'll give you a demonstration of one of these bugs in the latest version of OpenBSD. This is, let's see if this gives any better. Okay, so you can see, well, it's pretty small, and I hope you can read this. Basically, it's OpenBSD 4.0. I call it foo.mydomain. My ID is 1000. That's my user. Now I will run my super cool exploit, which I called blah. And now you're owned. Right. And this is basically a null pointer. And so this is basically a null pointer reference in the OpenBSD kernel. Ooh, well, Okay, so that was the demonstration, and I'm really glad it worked. The exploit's kind of stable, but usually when you're on stage, things have this tendency to blow up in your face. So I'm glad it didn't. Right, so basically what's going on is like, I actually found this bug, not by doing a